Lesson 4.2.2. Which trig tool should I use? Our goal for this lesson is the students will develop strategies to recognize which trig ratio to use based on the relative position of the reference angle and given size involved. So basically we're going to talk about shortcuts to figure out which trig. The same thing we did last time, but shortcuts to figure out which trig values you should use. Solve specifically right triangles. So like right here, our leading question is the triangle familiar. We're looking for only right triangles. What we're doing is only work for right triangles. There's something special about the triangle, has a right triangle, has a right angle. What side's opposite of the given angle? So right, when you have an angle here, the opposite one's always the one across from it. So let's do this. I'll put opposite in green. That's always opposite, like right, whatever your angle is, the one across from it's opposite. Hypotenuse is always the biggest side, the one opposite the 90-degree angle. That's hypotenuse, we got purple. And then we'll do a blue of adjacent. That's the one that's right next to the angle, but it's not the hypotenuse. So we have opposite across, hypotenuse is the long one across from the 90, and the leftover one I always think about is adjacent. So we have opposite, hypotenuse, adjacent. And a shortcut to remember how to do this, like which one's sine, which one's tan. Hopefully we know tan. Tan is opposite of adjacent. It's the delta y over delta x. But how do we remember all of these? The general shortcut way of doing that is this thing called SOHCAHTOA. SOHCAHTOA. And all that is, it's a shortcut to remembering all the sides. So sine, that's what S stands for, sine, is the opposite leg over the hypotenuse leg. So this means sine of theta equals opposite over hypotenuse. That's what that so part says. Like, hey, sine is opposite of hypotenuse. Then we have cosine. Break like this. Cosine is the adjacent leg over the hypotenuse leg. So it's just letting you know that cosine equals adjacent over hypotenuse. And then T is for tan, sorry. That's TOA, opposite over adjacent. So that's what tan stands for. TOA stands for. Tan is opposite over adjacent. And that's SOHCAHTOA. It's just a mnemonic device to help you memorize which one goes with which. As you see in a second, when you get a problem, what we want to do is label the sides. So you go, okay, here's my angle, this is opposite, this is hypotenuse, this is adjacent. And then look at what you have. It's right. You have two of these things, and it's either going to be sine, cosine, or tan. What's a quick way to memorize which one's which? SOHCAHTOA. SOHCAHTOA. So let's do a couple examples. So like here, I want to solve for x. Right. So first thing I do in my head is I go, okay, this is a right angle, so it's a SOHCAHTOA problem. And then I can also do my header in the paper as I actually highlight what I have. So here's my angle. Opposite is always across from it. This is always adjacent, which is next to it. This is hypotenuse. So in this problem, look what we have. We have opposite, there's an x there, so that's what I'm looking for. And we have hypotenuse. Right, so then we go opposite hypotenuse, what values I have. Look at SOHCAHTOA. This is O and H, so must be so. So this is a sine problem. So we just set it up. Sine of our angle equals, set up the ratio. Remember, O is on top, H is on bottom, so x over 17. And then we solve like we normally do. Put over 1, cross multiply, x equals 17 times sine of 22. Bring out your calculator. I got 17, turn mine on apparently, 17 times sine of 22. And I get 6.37, roughly. And that's how we're going to use SOHCAHTOA. It's just a device to help you memorize easily, figure out which trig ratio I have. Next problem. Martha arrives for her math test only to find that she has forgotten her calculator. Oh no. She decides to complete as much of the problem as possible. In the first problem of the test, Martha has to solve for the length x in the triangle shown below. Using her algebra skills, she writes and solves an equation. Her work is shown below. Explain what she did in this step. Okay, so this is a problem she showed her work. So first thing she did was set up the equation, right? So she highlighted, she probably did this in her head, but she's like, there's my angle. I got opposite Here's adjacent. Here's hypotenuse. So she probably in her head went SOHCAHTOA. And then she would look at, what do I have? We have O and we have H. Those are the ones that have values, so it's sine again. So she set up the equation at step 1. Sine of 25 equals the opposite over the hypotenuse. So she set up the equation. And then what did she do? Looks like she cross multiplied, right? She multiplied x by, like she put this over 1, cross multiply, x sine 25 equals 29. So she cross multiplied. And then she got x by itself, so she divided by sine of 25. Right, she solved for x. So she set it up, she cross multiplied, and she got x by itself in this case. This is a 2-step problem. Like, we've been doing a lot of 1-step problems. She got that. Marta's answer part B is called the exact answer. So anytime you leave it like that, you don't put in your calculator, it's called the exact answer. Now you can use your calculator to help Marta determine the approximate value. So if I want to do it with our calculator, we can do that. 29 divided by sine of 25. You get approximately that. And this is what I talked about before. Right, when I do an approximation, I do a little curly brackets to let people know, curly, like little squiggly lines, so that people know it's an approximation, not the exact answer. 68.62. So that's an approximation. Notice how this is an equal sign because it is an exact answer. They didn't have to round it at any point. Marta's teammate Ziv said she solved differently, but she had the same answer. He started with the equation cosine of 65 equals 20 over x. Explain why this equation must give the same answer. Okay, so he did some work. Okay, so let's go back up here. Let me erase what I did before. So he did cosine 65. So he did some work. He found this angle out, right? Because we don't have this angle yet. So he figured out what that angle was. He went 180 minus 25 minus 90 equals 65. So that's where we get the 65 from. And in that case, if you're looking at that angle, let's list the sides. Let me rewrite the triangle actually to help us out. So the triangle we have now is 65, 29, I believe, x, and 25. So her partner used this angle as the main angle. If that's your main angle, right, all the things change. What's opposite now? This side is. What's hypotenuse? That never changes. That's still this guy. And then we have adjacent over there. Right, now that we're using 65, opposite of 65 is now this side. So SOHCAHTOA. Right, look at the sides we have. In this case, we have the adjacent side and we have the hypotenuse side. So AH will have to be cosine. So we're going to do cosine of 65 equals adjacent 29 over the hypotenuse x. So that's what Ziv did. And it's the same answer because you're finding it's a proper way of solving it. If we can do the math, we get the exact same answer. Right, it's the exact same triangle, he just solved it, he's looking at it from a different angle there. Last one, solve for y in the diagram and write it in 2 ways using both sine and cosine ratios. Make sure that both ratios result in the same answer. So we're going to do this one here. So here's my angle. List out the sides. This is opposite. And this is a hypotenuse. Almost messed that up, sorry. This is adjacent. Based on this, we have the opposite side and we have the hypotenuse. Right? So SOHCAHTOA right here. O and H is sine. So we're going to do sine 53 equals y over 5. That. Let's cross multiply. 5 sine of 53 equals y. Put that in the calculator. We want to verify that these answers are the same. So 5 sine of 53. So we're going to get approximate value 3.99 is approximately y. 3.99 is approximately y. Now they want us to do the same thing with cosine. So if we're going to do that, I got to use this other angle here. So we got to figure out what this other angle is. So I'm going to do cosine, I'm going to figure out what that guy is. I'm going to do 180 minus 90, which is always 90, minus 53. And that should give us 37. So 37 degrees. Now, if that's my angle, all the sides change, right? Well, most of them. This is opposite now. This is adjacent. And this is hypotenuse. So in this case, we have adjacent and hypotenuse, A and H. Adjacent hypotenuse is cosine. So let's set up a cosine equation. Cosine of 37, angle I'm using, is equal to A over H. Adjacent, Y, over hypotenuse, 5. Cross multiply. Y equals 5 cosine of 37. Put that into our calculator. And we get 0.933 again. Right, they're the same triangle, we just solved it 2 different ways. So, you get the same answer, both ways. There we go. That's the lesson. Sokotoa.